Imagine the first sign of life beyond Earth isn't a grand announcement, but a faint, persistent whisper. On August 4, 2025, humanity stands at a new threshold. The James Webb Space Telescope has detected something unusual from Proxima Centauri's planet, Proxima b. This isn't a confirmed alien message, but a signal so peculiar it's ignited scientific inquiry and captured our imagination. For centuries we've wondered if we're alone. Now, science is listening more closely than ever. The quest for life is no longer just for dreamers, it's a scientific pursuit, using machines like the James Webb to search for signs of biology or technology. This detection is a pivotal moment. A single blip in the cosmic noise, forcing us to consider that the universe may be stranger and more populated than we imagined. The story begins with a telescope launched 1 million miles from Earth, and a rocky world orbiting a dim red star just over 4 light-years away. The signal is narrowband, a type of transmission on Earth almost always generated by technology. To find such a thing from another world is extraordinary. We must proceed with caution and skepticism, but also with open minds. If natural, we'll discover new astrophysics. If artificial, it's world-altering. It could mean another intelligence has arisen just next door, transforming our understanding of our place in the universe. The loneliness of existence could be replaced by the knowledge that we're part of a larger cosmic community. This is the story of that signal, and the beginning of a new chapter in our exploration of the cosmos. To understand the discovery, we must appreciate the instrument behind it, the James Webb Space Telescope, or JWST. Launched in 2021, JWST's massive gold-plated mirror collects more light than Hubble, letting us see fainter, older, and more distant objects. Positioned at the L2.1.5 million kilometers from Earth, its sunshield keeps it cold, crucial for detecting faint infrared signals. JWST's main mission: study the first stars and galaxies, watch planetary systems form, and analyze exoplanet atmospheres for signs of life. Using spectroscopy, JWST identifies atmospheric chemicals, potential biosignatures on distant worlds. Its 4 advanced instruments provide an unprecedented view of the infrared universe. During a routine observation of Proxima b, the near-infrared spectrograph detected the anomaly. Science often advances not by finding what we expect, but by stumbling upon the unexpected. The signal source is Proxima b, a planet orbiting Proxima Centauri, our closest stellar neighbor. Discovered in 2016, Proxima b is famous for its proximity, just over 4 light-years away. It's a rocky planet about 1.3 times Earth's mass, orbiting its star every 11 days. Despite its close orbit, Proxima b sits in the habitable zone, where liquid water could exist. But the environment is harsh. Red dwarfs like Proxima Centauri unleash powerful flares, possibly stripping away atmospheres. The planet is likely tidally locked, with one side in perpetual day, the other in endless night. Life, if it exists, might survive in the twilight zone. Still, Proxima b's nearness makes it a prime target for studying habitability. The James Webb Telescope was designed for such worlds, searching for atmospheres and their composition. During a long observation campaign, JWST captured the unusual signal. Proxima b's potential for habitability, combined with its proximity, makes it the perfect place to seek answers to our biggest questions. Every discovery here is significant for the future of space exploration. If we ever travel to another star, Proxima Centauri will likely be our first stop. This signal could be the first clue to what awaits us there. The detection wasn't dramatic, it was the result of painstaking data analysis. JWST observed Proxima b for 30 hours, seeking faint atmospheric signatures. Deep in the cleaned data, a narrow-band emission at 23.4 GHz appeared, highly unusual for natural sources. On Earth, such signals are almost always technological. SETI has searched for narrow-band signals for decades. Finding one from Proxima b is a red flag for astronomers. The signal drifted in frequency, matching Proxima b's orbital motion, a crucial clue. This suggests the source is within the Proxima Centauri system, likely the planet itself. The signal appeared in short, repeating bursts, not random noise, but structured and mysterious. Scientists at the Space Telescope Science Institute ran every diagnostic to rule out error or interference. No conventional explanation fit. The pattern of bursts is still under analysis, but its structure adds to the intrigue. The signal's origin is not terrestrial, nor from a satellite or background object. It's a structured, narrow-band anomaly from our nearest exoplanetary neighbor. The mystery deepens with every test. The scientific community split into 2 camps, natural or artificial origin. The first hypothesis is natural, perhaps a new astrophysical process we don't yet understand. The second, more speculative, is that it's a technosignature evidence of alien technology. It could be a beacon, communication, or even an accidental byproduct of advanced machinery. Scientists approach the artificial hypothesis with extreme caution. Extraordinary claims require extraordinary evidence. They're combing through decades of data, re-observing Proxima Centauri, and modeling natural scenarios. A repeat detection would be critical for confirmation. If natural, we'll learn something new about the universe. If artificial, it will change history. The investigation unites astronomers, physicists, and engineers worldwide. The answer is hidden in the data, waiting to be revealed. Before considering aliens, every natural explanation must be exhausted. One idea, a previously unknown maser microwave amplification in a narrow band, created by unique conditions near Proxima b. Another, the planet's magnetic field interacting with its star's flares, generating focused radio emissions similar to Jupiter and Io. There's also the slim chance of a background source perfectly aligned with Proxima Centauri. Or perhaps we're witnessing a new physical law or state of matter. Our knowledge of plasma physics in extreme environments is incomplete. The signal could be the first evidence of something entirely new. Science must remain open to the unknown. Sometimes nature is stranger than fiction. But what if the signal is technological? Several features are hard to explain naturally. Its extremely narrow bandwidth and structured repeating bursts suggest intentional transmission. It could be a beacon, planetary radar, or even leakage from alien technology. The frequency, 23.4 GHz, is in a quiet part of the spectrum, possibly chosen for visibility. An advanced civilization would likely optimize for detectability. The signal's clarity and specificity hint at purpose. Of course, this is speculation. Alien technology could be beyond our comprehension. Still, a narrow-band structured signal is the most efficient way to transmit information across space. Until a natural explanation emerges, the artificial hypothesis remains a tantalizing possibility. To grasp the significance, visualize the data. Astronomers spread starlight into a spectrum, searching for chemical fingerprints, dark lines for gases like water or oxygen. The Proxima b signal was the opposite, a bright, razor-thin emission spike at 23.4 GHz. On a graph, it towers above the background static, a startling anomaly. Mapping the signal's frequency over time revealed a drift matching Proxima b's orbit, the smoking gun tying it to the planet. This data-driven approach lets scientists compare observations with models of natural and artificial phenomena. Each new observation adds to the case for a technosignature or builds a new model of a strange natural process. The data is the ultimate judge. Right now it tells us something profound is happening 4.24 light-years away. The universe just got a little less silent. We stand at a remarkable moment. JWST has detected a narrow-band structured signal from Proxima b. Its characteristics defy easy natural explanation, and its frequency drift matches the planet's orbit. This could be the most compelling technosignature ever found, a whisper from across the cosmic ocean. The next step, confirmation. Telescopes worldwide are now listening for a repeat. Independent detection is critical to rule out error. Meanwhile, theorists are racing to model exotic natural phenomena that could explain the signal. Regardless of the outcome, this event has changed the search for extraterrestrial life. Our technology now lets us detect potential signs of other technologies across interstellar distances. This single detection will inspire new telescopes and search strategies. We've opened a new door in our cosmic exploration with no idea what lies beyond. For the first time, we have a specific, tantalizing clue that we might not be alone. The universe is vast, mysterious, and full of surprises. What other secrets await in the faint light from distant worlds?